Hi class, this is part 1 of section 2.3 on lines. Describe the slope of these lines. Okay, so take a minute and just think about which words you would use to describe the slope of one or more of these lines. Okay, you may have said uphill, rise over run. You may have talked about the steepness of the line. One student described this horizontal line as neutral. That would be another good word for it. Positive slope, negative slope. Okay, all of those would be good words to describe the slope of a line. Okay, so we have our slope formula. So again, slope is rise over run. The rise is the change in the y values. The run is the change in the x values. So if we go from the point x1, y1 to the point x sub 2, y sub 2, we can see that the change in y is this vertical distance here on our graph. So this distance is going to be y sub 2 minus y sub 1. Okay, so in this picture, 3 minus a negative 2, so 5 units total. 3 minus a negative 2, or 5 units. The change in x sub 2 minus x sub 1, x sub 2 is 2, and then minus a negative 8, which is 10. Okay, so the rise over run in this picture would be 5 over 10, which you would reduce to 1/2. Okay, this formula works as long as those x values are not the same, so x sub 1 cannot equal x sub 2. All right, example number 1, find the slope of the line. So remember, the slope is rise over run, or the change in y over the change in x. So pick 2 convenient points on the graph. I chose -2, -1 here in the third quadrant, and 4, 3 here in the first quadrant. Okay, so those are places where the line went through a nice ordered pair, right? 4, 3, as opposed to having to worry about fractions. Okay, so the change in y is how far up we need to go to get from a y value of -1 to the y value of 3. Okay, so we went from -1 on the y-axis to 3 on the y-axis, which is a total of 4 units. We then have our change in x, right? How far do we go to get from -2 on the x-axis over to +4? Okay, if you count them, you'll see that that is 6 units. So we went up 4 and over 6. So rise over run would be 4 over 6, which reduces to 2/3. Okay, example number 2. We still want to find the slope of the line containing 2 points, and this time we'll do it algebraically as opposed to looking at the graph. So we'll use our formula. M is equal to y2 minus y1 over x sub 2 minus x sub 1. Okay, so for the first one, start with the second ordered pair, so 10 minus 4 over 2 minus a -6. At this point, I would just double check to make sure you haven't, put the numbers in the wrong place. As you look vertically, so 10 is right over 2, so 2 and 10 should have been in one ordered pair, which they are, and 4 and -6 should have been together in an ordered pair. Okay, sometimes students will write 10 minus a -6 over 2 minus 4. Something like that, where they have the right numbers, but just not in the correct order. Okay, in the numerator, we'll get 6. In the denominator, remember this is 2 plus 6, or 8. So our fraction reduces to 3/4. Okay, part B, M is equal to 8 minus 8 over -2 minus 3. Well, 8 minus 8 is 0. -2 minus 3, remember this is -2 plus a -3, so it works out to be -5. 0 over -5 is fine. This is allowed. This is the number 0. Okay, so I mentioned before, one way to remember this is that pretend that 0 is an egg. If you have an egg on top of a fraction, it's fine, right? It remains an egg, meaning we keep 0. If you have 0 in the denominator, so let's say I had a 4 up top and a 0 in the denominator, having an egg in the bottom is not good, right? Your egg would get smashed. So this expression 4 over 0 or anything over 0 is undefined. Okay, but a 0 in the numerator, you're good to go. Okay, finally part C. 3 minus 5 over negative 1 plus, sorry, I was getting ahead of myself. Negative 1 minus negative 1. So again, minus a negative is really a plus. So in the denominator, I have negative 1 plus 1. Okay, so I have a 0. The numerator, I'll also simplify. We have negative 2. Okay, so negative 2 in the numerator, a 0, or that egg in the denominator. This is not allowed. The egg gets smashed. This expression is undefined. Okay, and let's take a moment and think about what's happening with their graph. If the slope is 0, okay, think of that as being out for a nice walk, okay? If the slope is 0, so here's your x and y axis, your coordinate axes, okay? If you're out going for a walk and the slope is 0, that's fine, right? You're just walking along a straight line, a horizontal line, okay, not a problem. The slope is 0, nothing bad happening, right? We just get a horizontal line. If it's undefined, if the slope is undefined, that's, you know, not as desirable, right? Something undefined is less desirable. If you're out for a nice leisurely walk and then you come across this vertical line that you have to get up, right? You're in trouble because it's difficult to walk up a vertical line, right? You're come tumbling down. Okay, let's plot these points. So 3, 8. Let's say this is a 3 along the x-axis and I go up 8. Negative 2, 8. Notice that these points are in the same horizontal line. Negative 1, so I'll draw another graph here. Negative 1, 5. Just put that right here. And then negative 1, 3. Still in the second quadrant, okay? These 2 points, when you connect them, we see that we get a vertical line. Okay, so anytime the slope is undefined, you have a vertical line. Anytime the slope is 0, you have a horizontal line. Okay, good. Also, when you're given those ordered pairs, you can plot them and see what they look like, right? Do you connect them vertically or horizontally? Okay, complete this one and turn in through Canvas. So part D, same direction. So you want to find the slope of the line containing these 2 points. All right, example 3, graph the line that contains the given points and has the given slope. All right, so we want to graph the line that contains the point 2, 3. Start by plotting the point 2, 3. So you go to the right 2 units, so x value is 2, the y value is 3, so you're up 3. The slope, or m, is equal to 2. Sometimes it's useful to write this as 2 over 1, because we want that rise over run. Okay, if I'm here at 2, 3, and I rise 2 units and run 1 unit, horizontal change 1 unit, here at 3, 5, right? You might say, well, I'm so close to the edge of the graph, can I go down 2 units? And the answer is yes. But if you go down 2, you have to then go to the left 2, sorry, to the left 1. Okay, so if your rise is negative, you're going down. If the run is negative, you're going to the left. So notice that these 3 points all lie on the same line. Okay, so you don't have to do both. If the slope is positive, go either up and to the right or down and to the left. Okay, the next one, this time the graph goes to the point -1, 1. So we're here in quadrant 2. The slope is -4/5. As it was written in the question, that negative is kind of out front, but I rewrote it with the numerator. So from my point, -1, 1, I would go down 4, 1, 2, 3, 4, since the rise is negative. So you go down 4, 1, 2, 3, 4, 5, to the right 5 units. Okay, and we're here. You also could go up 4 units. So treat the rise as positive, so 1, 2, 3, 4, but then the run as negative. 1, 2, 3, 4, so we'd be a little bit off the graph. Okay, connect them. Good, and there's a sketch of our line. Notice that in part B we had a negative slope, and our line is going downhill. So we always read graphs from left to right, just like you read a book from left to right. So looking at this red graph from left to right, it is going downhill, meaning it had a negative slope. In the first one, part A, the slope was positive. Okay, so again, going from left to right, this line is going uphill. So that's a way to check to make sure that at least positive or negative, the slope matches what it's supposed to. Okay, and then here's the 2 lines graphed on Desmos. All right, example 3, part C, you guys will do this one and turn it through Canvas. So graph the line through the point 3, -1 with a slope of -2/3. Okay, and then this slide is just to help you. A few things that we've talked about already. Slope-intercept form of a line came up briefly in an earlier section. That is our y equals mx plus b. M is the slope of the line, and the y-intercept is the point 0b. Point slope form, this guy right here, y minus y sub 1 is equal to m times the quantity x minus x sub 1. Again, m is the slope. This is a line that contains the point x sub 1, y sub 1. When I do examples, I'll use both of these forms of the line, both point slope form and slope intercept form. You'll eventually want to get used to this second equation if you're not already. Okay, and it will be helpful in your next math class. The third one is the general form, ax plus by is equal to c. And then we have 2 special cases, a vertical line. So remember, a vertical line is when the slope is undefined. So we can't solve it for y if this m is undefined. It's not going to work. So this is the line x is equal to a. That's going to give you a vertical line. A horizontal line is when m is equal to 0. Okay, so if I go back here to point slope form, if m is 0, 0 times x would be 0. So that would go away, and you're left with y is equal to b, right, which is the equation we have right here. Okay, good. That's all. All right, so good luck with those lecture question problems, and let me know if you have any questions.